so boring to take part, and they have a ton of recognitions. We won every stuff ever. Yeah, we got every single one. We probably spent like $50 between all of us. We went home and we had like 10 stuff ends. That's so legit. That's so cool. I'll be so close to be able to like. We played songs. Are they in Seattle? Yeah, he's on the Who's better? They lost it in the last.
We tied. Oh no, you're right. We tied. They scored a goal like the last minute to tie the game.
Plus, I don't think they have I was able to play with 2 teams. So I think once
that was like their midfield.
One played for Roca?
Yeah.
He played for Arsenal. Why? And then I don't think he pushed them anymore, so they kind of lost him. That's like, wow. Roca just got signed. Like to one of their youth teams? To their youth team. That's crazy. That's the national team. That's insane. That's so insane. You go to he's like, he just got signed. There's a bunch of stuff on that. I was like, oh, I know exactly what that's like. Or they just
I know if I start,
I knew I was going to leave he plays for oh, that's yeah, I didn't cry. She wanted to go there this summer, but she didn't
he didn't say anything about it, so I was just like, just chill. I can't believe it. It like blows my mind.
You just gotta get mom on board.
It's pretty funny.
Yeah, that look at
I got the right answer. When I made it, I don't know if it was you that he cried. I made him, obviously, he cried at the time. I know. He was just small. I didn't even realize that. Because if he hadn't seen it, he would have got bumped off.
You could be in my class. You have to get in my class.
Did you finish the packet? Just bring the calculator. Sorry. Finish the packet. Steven, calculator. Steven,
I don't have a calculator.
did you finish the packet? Did you finish the packet?
Is there a calculator?
She is so amazing. I had her last year. She's like my favorite chicken arm.
What do you have?
Oh yeah, there's 7 bucks.
Then I would be ready.
just talk about it.
It's not hard. It's not, you don't really even need to practice. Are you in our group?
Something so. I didn't say anything because I wasn't sure.
Darius, I'm talking to you.
Oh.
I said I'm not talking to you.
Something's different.
I'm going to be in the
Why?
Like, took a part.
You guys have a phone?
No, I invited Sam to come with my face.
So who's in our group? Who'd you ask? Why'd you dip on us, guys? It's not
Left
cool.
was like, right,
Different better things around and
No, well,
like screw these guys.
my guys are right in the one of my games, so I just
one of like midpoint was like oh no, the midpoint was like
it's face down, so it's going up and then
Oh, these are the he has no worries. We feel like process he's going through, so like they just like I just come in. He has no worries in his life. Can you imagine how nice it would be dying? Everyone's right there. Not a question. You see everybody diverging in their mind. Bro, we're just dead. We're not dead. It's got a snap fast. It opens up. Reevaluate. VIP. It's got a pack. You know, like a pack.
Yeah, look up, please. Okay, with the new term, we have to pick new seats. So, same as before, you create a seating partnership. Triples work. I can even take a group of 4, but if you do a group of 4, you have to agree to pick the ends of the rows, not the middles. So, pack up your stuff, find a partner, I'll bring you a ticket later.
Hey, we did something like that. Touche. So is everyone staying in this thing?
Give us some money. Here are a couple hundred He's gonna hit it. I think he might hit it. I don't think he's above this.
I can't remember anything.
He's down there at all. I've never seen him. I feel like I've seen him once, but I couldn't recognize which one's it.
Yeah, I probably could. I do too. I'm TA with Blake.
I actually might be like super intimidating. He tries to be. That's why he's doing this.
I know, don't say it. If you hear me out loud, say, I can give my
Yeah.
What do you have tomorrow?
Yeah,
I feel like he's still sick though, even when he's like sometimes. had it up to that'd be so cool. What? How are we doing? Switched to English instead because everything fell apart. Because they switched to
Need to watch that one first.
Yeah, yeah.
Adam actually changed the egg white. Shoot great. You too.
That'd be a lucky one. You guys have to shoot.
No, you just keep going. At least
It's so weird.
That's hilarious. I would work on it too.
You sat there like every turn. We need I've never sat.
so much nautical.
Hey, but I'm struggling.
That turned out to exactly the right size.
What did you end up
I
getting?
respect her. He probably did it until he probably like redid the coils in different sizes until
I just opened it up after taking it.
even that one because it's bigger.
11.958. That's the number you need.
God, I thought about it, but what if he's like was super size? High risk, high reward.
5895. Come on.
It's the last three digits. 902.
We finally got first.
Yes.
900.
Same going on. Why would you throw it through?
907.
But you already had it. I think get on my phone.
904.
What did I do to Mr. Ted? Not pick my number.
899.
Oh! Serious. 895.
896.
Oh my gosh. Oh, that's us.
Where are we going? Viable.
Don't take drugs. I won't pass it to you all year if you take drugs.
Yeah, we're good. You can do these three. You can leave that one. That makes sense. Yeah, that works because that's kind of wise. That's satanic.
I mean, everyone's just teaching.
903.
Yeah.
They know.
No. Give it a word.
897.
We have to do an event.
It's literally bouncing around us.
If it doesn't fit for the tree, Mary's pretty flexible. We can.
We'll sit by her. We can squeeze her in by us.
She's pretty flexible. 895.
Transfer the paperwork, try again.
8-4 is really small. 8-4 has like 23 people.
I can't do it.
908.
Oh my god.
908.
We floated was really fun. It's good colors. And more than we thought.
Well, I think we're probably going to be the last.
What are the odds?
You're blaming me.
Yes, I am.
You still want to make college.
901.
I'm really sad.
This is a bad angle. We like that.
No, we are going to do it.
893. Okay, well, where are we going?
Wait, is there even enough to share?
We're going to be like all
It's okay, you know? It's a good thing that you're first I would say like middle rather than that.
8, 9, 8.
Yeah, finally.
Okay, now that table's open, that table's open. If you want to split up, there's a seat here that's open, there's a seat there that's open. So it's your choice, man.
I'm just gonna go, yeah, and then I'll just go like this. Me, you, and Mary. Yep. Unless they're going here. Are they? Okay, me, you, and Mary. Somewhere else. No, it's totally good. There's a chair over here. Me, you, and Mary. Oh, you gotta take it? Oh, there you have it. Okay, go somewhere else. Wait, there's three right here. Okay, let's do that. Me and Mary. Anyone disagree?
It's always an adjustment for me as well. Just to get used to everybody and then they'll move.
I sat in the front and I sat in that spot. No wonder you if I can't see with my glasses, it's like
Everybody, all right. Look at me. Okay, since it's been a couple weeks, we got to kind of get back to what we were thinking about before the break. So today is a little different. I'm going to give you a quiz, but this one you can work together, you can use your notes, and there's no penalty. You can ask me for hints, whatever. I just got to get you thinking about what we were discussing prior to the break. So work on this quiz while I make a new seating card. Go.
No, but I said Theorem was just red. Why was this the last spot? Because it's not a good one. That was the spot I got and now you're back here. We're like it's so big. I'm checking. Well, they're supposed to be. We'll keep early. Are you using here? second of what? No. Remember we only learned the second of seven? Oh my gosh, we need to do that first.
Hey, look up for a second. Look up for a minute. Okay, again. We can fix that. One moment. There we go. Okay, we're just trying to get back to where we were before the break a little bit. So the FTC, the fundamental theorem of calculus, you need to have this memorized. But this is what you should be thinking of when you read the words fundamental theorem of calculus. You think to yourself, hey, if I integrate the velocity, on this particular question, they're talking about time equal 1 to time equals 7. So let's see, I want to integrate from time equal 1 to time equals 7. I'm going to integrate velocity multiplied by time. The way I remember that is if I think of some velocity like 10 meters per second. If I multiply that 10 meters per second by some amount of time, 5 seconds, the multiplication, the product gives me 50 meters, which would represent the change in the particle's position for those 5 seconds. That's where this comes from. So we memorized that this integral is always equal to the change in position. Time equal 1 to time equals 7. So you need to have this thoroughly memorized. Not like get it memorized. So that's what we were kind of where we were before the break. And then we also talked about how instead of writing the words change in position, we can symbolically represent the change in position as the position at time 7 subtract the position at time 1. So that's the same thing, just written with all symbols, no words. So this is the fundamental theorem of calculus as well. Watch people take notes so I know what you got. But remember, I've said before, this is not a plug something in, get something out formula. This is a formula that contains 3 different values. You've got the integral, you've got the position at time 7, the position at time 1. So this equation can be rearranged in any order to, whatever purpose you need. But this is the basis for many of the quiz questions. So right here it says, use the fundamental theorem to come up with an equation for x of 1. Well, I can use this equation algebraically rearrange to get x of 1 equals, or x of 7 equals, or whatever I'm trying to solve for. Right?
Can you re-explain what the 10 meters and the 5?
Right here.
Yeah.
So this was an example of this right here, where when we're integrating, we're taking velocity multiplied by change in time. So if it turned out that the velocity happened to be 10 meters per second for a 5-second time period,
Oh, okay.
that would tell me the particle's position would change by 50 meters.
Okay.
No, it's a good question, Terrence. Point. It's why we integrate velocity times dt. So there you go. Cool. So that should give you enough of a hint to get this one done and get this one done. Then this one you have to use the graph. So let's work for another minute here. Keep going. Right, because the input cell, well, yeah, second just says write it in. Right. Yeah, it doesn't say compute the integral, just what you
Well, the graph.
If you need a hint, you can always stop me too.
Oh, this is 4. This is what I wrote. Right? So this is 10 minus shape 1.5 equal
No, you can't count the position. No, so the idea is using that fundamental theorem, we can find different positions. Question number 1. Okay. Raise your hand. We're just going to kind of check as we go, and then I'll let you work some more because we're trying to review a little bit. Hey, number 1, please. Raise your hand if you have something written down for number 1. Show me your hands. Come on. Who has something written for number 1? So, Tessa, what did you write?
X of 1 equals X of 7 minus
Yeah, that's correct. So how many have that written on the paper? Show me your hand. Mark down 2 points. Okay, so look, the other question I had just a second ago, look at me, was somebody noticed correctly that this is a graph of velocity. So I can't read the graph and find position. It's not possible. But the fundamental theorem is the connection I need. Because this equation, this is really the fundamental theorem just rearranged. It's telling you if you want to know the position at time 1, well, you have to know what the position is at some other time. But then using an integral, and we learned how to do integrals before the break, you can then find the position at 1. Keep going. Usually easy numbers, it's easy to talk about. Say, okay, let's see. I end up at position 20. Well, for the previous 6 seconds, my position changed by positive 15. Oh, I must get that at 5. That's all I got. So if you're asking for a hint to test anything.
No, it's 1.5. So, did you get 97 for 1?
So the question was asked, well, how do we, just struggling to remember a little bit, how do I do this integral? Okay, just look at the symbols, and the symbols will tell you what to do. You're taking velocity multiplied by change in time. And you're doing that from time 1 to time 7. So over here, I'm starting at time 1, stopping at time 7. Well, my problem is I have 3 different velocities. So I cannot do an integral from 1 to 7 with just one velocity. I've got to use all 3. So that should be maybe a big help you. Don't forget the big S stands for sum, like to add them up. So, keep on. Just like it says, velocity multiplied by change in time. Just as it's written.
I'm like, you feel like I'm excuse me, I can't see her. Yeah, so, and then, that might be good. I get Thank you so much. I was trying to just there with the very good, thank you. Give me my final
Hey, look up, please. Hey. Look up. And Risha, if you have something written for number 2, please. Show me your hands. I got to see how we're doing, so make sure you show me your hands. Who has something written for number 2? Jake, what do you have?
Integral of 1 to 7. Negative 3.5.
Nothing wrong. Quite well, teeny bit off. No worries. 2 points for contributing. When it says write an integral, we don't want to do computations. We just want the integral itself. There's a difference between, look, it's crucial. Difference between the integral and how you compute the integral. So, somebody else, what do we got? What do we got? Let's go, Kurt.
So integral of 1 to 7, and then dt.
Stop right there. That's all you need on number 2.
Oh.
Number 2, it just says write the integral. So here's an integral. If I calculate this integral, the integral's value will represent the change in position. Okay, right and wrong isn't so important today as it is making sense of this. Remember it. So hey, show me your hands if you have this written down. Show me. I gotta see how we did. More points? Okay. Now on number 3, we're going to compute this integral. So you didn't have to write down the computations, but I want to put them on the board so everyone can see them. So somebody knows what computations to write. Ellen, talk.
Okay, so you write 1 to 7.
Should be doing that. Yep.
and then it's negative 3.5 times 2.
Hold on a second, I'm tight on space here. Keep going on.
Plus 1 times 1 plus 2.5 times 3 and
1 second, sorry. What was the result, Alex?
1.5.
Can we have 1.5 written down on the paper? Please show me that. Show me that. Who has 1.5? Show me. 2 more points. We want to talk about it. Questions? Are you okay with these 3 things?
Yeah.
So you just typed it in wrong. Anybody else? Hey, number 4 is basically saying go back and use this equation now. They tell us the position at time 7 is 10. We figured out that the change in position was 1.5. Therefore, this has to be 8.5 feet. Show me hands if you have this written down, please. Show me. Who has this? More points? Show me if you have something on number 5, please. Actually, let's talk for a second. Hands down for 1 second. Hands down. Okay, the easy way to remember number 5 is this. Look at the graph here. Look at velocity. You just say it out loud, please. For this time period, is the particle moving left or right? Say it. Left. Are we good? For these 2 particles moving right. When we calculate change in position, that difference is important. So we have to account for the fact that the velocity is negative versus positive. But when we want the total distance traveled, we don't want any of the velocities to be negative. So hands up if you have something written for 5. Show me your hands. Who has something written down?
I got 15.
Louder. 15. So that's actually 6. The answer to the computation. 2 points for that. I just want the integral here. Who has the integral written down?
Just before, is it from the whole time that's shown on the graph, or is it just from the same?
Oh, so bad question. Look up. Yeah, the question didn't specify, so that's my fault. So either one would be fine.
Okay, so I said the whole thing was so it'll go from 0 to 8, and then absolute value dt.
Who has this written on the paper? Show me. Who has this written down? If you wrote 1 to 7, that's fine as well. So either has this or 1 to 7. Either one is fine. More point. And then what was the computation? This one here?
Yeah.
So are you okay with number 1?
Yeah.
So number 1 says the position at time 1 is whatever the position ends up being, which they told us right here is 10. So this is 10. And then we computed that the particle's position changed by a net amount of 1.5. Is that your question? So Nate, what'd you get for this one, the 0 to 8? I haven't finished that one yet. Keep working for a minute, go. Okay, so this one actually,
Number 7? Oh, I didn't even see that. Oh my god, thank you for telling me.
because
If you were
the position of time 8 is the position of time 0 is the change in position. And the change
This is going to work.
this change in position, this is counting time is velocity would be. So it won't tell us how the position changes necessarily. that? What purpose?
I don't know.
Oh, that's funny. No, I think you're fine. You actually thought it was what you said it wasn't really quite what you had. Take a look at your laptop. Hey, hands up. Who has an answer on 6, please? Hands up. Come on, show me your hand. Show me your hand. Who has an answer for 6? Show me your hand. Kid has an answer. Show me your hands if you have an answer for 6. There we go.
Oh, 21.5.
For this integral here. Hey, raise your hands, please, if you have this written down. Who has this written on their paper? Show me your hands. Show me your hands. 2 more points for that. Anyone do the integral 1 to 7 instead? What did you get?
15.5.
So 15.5 would have been the distance traveled 1 to 7. So that would be fine as well.
So why did that work?
So 1 to 7?
Yeah, why not?
Oh, it wasn't specified.
Oh.
Yeah, because that's a bad question. The question doesn't say for what time period are we trying to find the total distance traveled. That's my mistake. Yeah. So we've already talked about a lot. This would be x of 7 subtract x of 4. The question says, what's the mathematical expression? So expression technically means just this not equal to this. What it would equal would be this. Okay. It would equal the integral, or you could just say it equals change of position. Either way. So the reason I gave you the question, Kate, is I'm trying to get you more and more comfortable with the idea that this equation right here can be used a lot of different ways. So everybody look at the board. Kate's question is very timely. Yeah, the whole point of this is, the whole point of the quiz is this. Have this memorized. Know that you can calculate this integral by taking velocity multiplied by change in time to calculate the integral. Once you have the integral calculated, recognize from this equation that the integral is finding these two things subtracted, which means the integral is finding change in position. That's what you have to have memorized. But also know that you can rearrange this equation to solve for different things. Like I could solve for x of 7, or I could solve for x of 1. In fact, just really quick, just for extra credit, super easy question. On your paper right now, here's one version of the fundamental theorem. Write down another version that instead of starting out the integral equals, I wanted to say x of 7 equals. Just write it down, please. What's the theorem going to look like if we write x of 7 equals? The position at time 7 is equal to what? Write that down, we'll pay extra credit for this. Watching the pencil. So read back what you wrote, Laura.
Integral 1 to 7 of dt plus x equals 1.
How many have that written on their paper? Show me that. 2 points. Okay. Then the other one we did was in the quiz where we wrote x of 1 is equal to x of 7 subtract the integral. these are just different versions of the fundamental theorem, okay? Okay, this one here, look. When we calculate total distance traveled, it's not the fundamental theorem anymore. Total distance integrate 1 to 7 absolute value. Any questions? Okay. Because of the break, we're kind of resetting here, so the scoring today is really easy. So everyone just gets 10 for today's quiz, just for being here. Okay, look at me. I need your help with the scoring because people changed classes, so it's a little confusing. So look at the board, like concentrate. Okay, look at the. Okay, this has the first 2 quiz scores that we did before the break. So quiz A and quiz B. So what you're going to do in a minute here is you're going to look at your first 2 scores and pick the best one. Just pick the best score from these 2. Got it? So some of you have to flip to a different period, but you'll find it. So pick the best score, just one score. Add that to 10 because your score today was 10. So like maybe my best score was 7. I add that to 10, I get 17. It's a good Christmas break. Okay. Guarantee I did no calculus. Okay. 17. Divide 17 by 2, you get 8.5. Round up to 9. So on this sheet, which is the new class, like the new term, you're going to write down under quiz ABC, you write down 9. Because I take the best 2 scores. And that's what goes in your grade. So one more time, look at this one. Find the best of the 2 scores that is written down. Maybe that best score is 5. You add that to 10, that would give you 15. Divide that by 2, that gives you 7.5. Round up, that's 8. You write down 8. If you finish the packet that you were supposed to have finished in class last time, or actually I was hoping you finished before the break, mark that down as 10 as well. So, any questions? Okay, cool. Cool.
I was just like, I've always respected all this goal for drinking, and I never do it. So I was like, I'm just gonna go infinite and I do things as quickly as I want to there. I would monster come with me, and then like I made up a calendar, and so it's like do it, mark it off every day, and then I might carry me into the next month. I chose to read the scripture for 30 minutes a day, and I've done it multiple times. You know, I'm really reading through I got like 20-ish days for that. I'm gonna do it. Do it. I just like had like
Some of the names got all scrambled. Because I came to you, and I thought, Kenzie, but Kenzie's over there, but now I know why I thought Kenzie, because Kenzie's your sister, right? That's why. They're all mixed up again. Yeah, we'll start using the calculus. That's why it's there. No one talked to him. No one talked. No one talked while I talked. Look up. Okay, so far we've talked about integration. And we talked about how integration can be used to find, look at the board, come on, look at me. Find change of position. Okay? Today we start, well, we're going to talk about how integration can be used to calculate something else. And the basic idea is simple. Here, all we're doing, as David mentioned earlier, is you're taking velocity, you're multiplying by change in time. Velocity multiplied by change in time. When we do a multiplication, that gives us change in position. But we can also, that's what Paris asked about up here, okay? We can also do a multiplication like that and find something else. So if you flip the packet I just gave you to the very back, just flip it over. So you see this image. Okay, you have this image, look. And I'm going to outline a really simple idea. And if I need to say it 3 times to make it stick, just keep asking me to repeat it. It's not a big deal, but it's got to stick. You can't just nod and say, yeah, I get it. If you don't get it, you got to talk to me. Okay, we want to use integration, focus, to find the area that you see outlined here. So this complex shape, we want to use integration to find this area. The reason it turns out to work pretty easily is this. If you divide the area into rectangles, like I've done, finding the area of each rectangle is relatively simple. I can look at the graph and simply observe what the width of the rectangle is. So for extra credit, raise your hand if you can tell me the width. Don't try it, just raise your hand. Look at the graph, look at your paper. Raise your hand and tell me what's the width of every rectangle. What's the width of every, look a little closer. Look close to the decimal points. What's the width of every rectangle? Show me your hands, show me your hands, show me your hands. Allison, what do you got?
0.1.
How many knew it was 0.1? 2 points, okay. So the width is easy. Look, the length really isn't too much harder. Look at the board. Okay, to find the width, what you really did is you took, you know, this says 0.4 for the x-coordinate. This says 0.3 for the x-coordinate. You simply took the x on the right and subtracted the x on the left. You'll hear me say that for the rest of the year, because we're going to use it frequently. X on the right, subtract x on the left will give you a distance on the board. The same thing is true for vertical distances. If you take this y-coordinate and you subtract this y-coordinate, you get the length. So we take length times width, we can find area. That's why we can use an integral to find area. This length times width. So we're going to kind of step through the details of that. But we got to get this on your calculator first. So graph this on your calculator. Go. You don't have a calculator. Pay close attention to your neighbor. Graph that. You're not going to graph the rectangles. Just graph the. So your calculator should end up looking like this. No, this is. That's what you should get 10. So if you've forgotten, so we have y equals. Type in one equation and type in the other.
Which one is on top?
F is on top.
That's on top. Where's that?
If you're having trouble, just ask me. Oh, you've got this shading thing turned on. So let's just get rid of that. So go to seconds, memory, reset, all red. So reset. Now. Look at me, please. Look up. Everybody look at me. When you're doing the calculator, it's hard. You got to come back. So look at me. Look up. Okay, for calculus, there's a certain feature that a lot of people don't know about. You need to know about this for calculus. It becomes something you use a lot. And getting it windowed properly makes a huge difference as to whether you'll answer the question correctly or not. So here's my recommendation. On a problem like this one, windowing is really easy because they're showing you the window. You're supposed to start at x equals 0 and stop at x equals 1. So on the calculator, hit the window key and set your x min to be 0 and your x max to be 1. Don't change anything else, but do that. Once you've done that, hit the zoom key, and the zoom feature I like best is zoom fit. Zoom fit is not shown here, it's item 0 on the list, it's the next one down, but I don't like scrolling, so I just type 0. And then that's all you gotta do is wait, you don't have to enter anything, and then we'll window it properly.
Wait, mine says invalid dimension.
So I'll come, hold on a second. What am I gonna bring treats?
Definitely not.
I'll bring treats today. You bring
Yeah, you did. Yeah, we did.
Hey, look at me. Hey, don't talk. Don't talk when I'm talking. A quick story to impress upon you the importance of understanding what I'm going to show you. Okay, one year during the AP test, at the break, someone came and talked to me, and they reported that really one of my best students, it was her friend. During the test itself, they kind of, you can't look around, they'll kick you out for cheating, but she kind of noticed out of the corner of her eye, right, that her friend right here was crying. Like, true story. What had happened was, I'm serious, like it was the calculator section of the test, like listen, this is super important. Calculator section of the test, and this student, really one of my best students, she was crying because she couldn't get her calculator to work. Like she knew what to do, but she was just, the frustration overwhelmed her. Okay, what happened, I think, is what just happened to Allison's calculator. It's a good opportunity to show everyone so you don't ever have this problem. You watch me. I don't know exactly why, but when you're pressing a lot of keys and you're kind of in a hurry, it's very common to accidentally get that button right there highlighted. So in the Y equals menu, they get the plot turned on. You turn it off and on by highlighting it with the arrow keys and pressing enter. So now it's on, now it's off. Okay, if that's turned on, most calculators, when you go to graph, you'll get this error. don't worry about the error itself. What's important is to get used to looking here and making sure that when you're under y equal, for our class, you don't have clock turned on. That's for statistics. So just highlight it, turn it back off. Now the good news was, once you kind of got over the emotional trauma of the calculator not working, she was a really good student. She kind of calmed herself and she was able to figure it out. But really, make sure you know how to fix that. So. Okay, who has this on their screen, please? Hold up your screen if you have this. Show me your screen. Just show me your screen. I'm just going to look around the room. Show me your screen. Who has it? Mark down 2 more, please. Okay, really simple. Look, we need to find this point. Okay, we've already talked about that that point has an x-coordinate of 0.1. That point has a y-coordinate that we could call f of 0.1. The actual numeric value can be found on the calculator by doing this. I hit the trace key. The calculator is waiting for me to specify an x-coordinate. So I type in 0.1. And it tells me the y-coordinate, 0.18. So I'm going to write that down. Okay, on your calculator, make sure you can get that to have to do that right now. Make sure it works. And then just raise your hand if it doesn't work so I can help you. Make sure you can find that y-coordinate as being 0.18. You would need help. Okay, we need to find this coordinate as well. So this one is 0.1 again, and g of 0.1. So it's 0.1, and to find that coordinate back on the calculator. Okay, here's a problem with the calculator. I'm going to down arrow. That will move the cursor from the f of x to the g of x. But it also changes the x coordinate. It shouldn't, but it does. So I type in 0.1 again. We always round to 3 decimals in this class. If you don't round correctly to 3 decimals, you lose points on the AP test. So negative 0.854. Does anyone need help getting their calculator to do that? Okay, look. Bell's going to ring in a minute. Listen. First day back from the break, we're not quite ready for homework, so watch me. So no homework tonight. Make sense of this. Hey, make sense of the idea. If you make sense of it, we'll stick. All we've got to do is take this y coordinate, 0.18 above, subtract from it this y coordinate. The subtraction will change that to positive. They'll be added together, and you'll get the length. Show me 1 to 5 if that makes perfect sense. Don't leave, don't leave. Yeah, thank you. Good. Watch me, watch me. So really, I'm going to write down one thing or write it in your notes. It's really easy. All we're doing is we're taking the f value, that y coordinate at some x. We did it for point 1, but you can do it for any of them. You subtract from that the y coordinate on the g function. Okay? That gets multiplied by the width of the rectangle. The width of the rectangle is a change in x. That's why it's called dx. We want to do that repeatedly and add them up. That's integration. So we put the big X. We start at x equals 0. We stop at x equals 1. That integral will compute the area shown by just doing rectangle after rectangle after rectangle, just one after another. We'll pick it up from there next time. Good job. Yeah, we'll fix that next time as well. But that's a perfect observation. Perfect.